don't know why I keep doing this. I mean, having ideas for an explanatory video, then going down the rabbit hole of whether it actually works or not. But here's Z-Hop, overanalyzed. Let's go. This video is sponsored by PCBWay. Z-Hop is this. Do you see that? There. Before moving from one part of a print, you retract, and Z-Hop is the additional act of raising the nozzle during that retraction. And I'm not going to waste your time if you just want to know what to do about it. I'm going to convince you during this video that it needs to be turned off in almost all situations. Emphasis on almost all. A lot of printers have default profiles with Z-Hop on, and I've been seeing more of that recently, but in all my testing, I do not have a good enough argument to support that being a good idea. In my opinion, Z-Hop needs to be off as a default because it will cause print quality problems that will be quite hard for you to diagnose. If you want to leave now, go ahead, but you might miss the fun. I mean, maybe there's fun. It might just be boring, it could just be a huge trick to get you to watch to the end. Anyway, let's refer to the manual and see what Z-Hop is supposed to be for. It's pretty much what I just said, but it goes on to give us a diagram of exactly what I did just say. The interesting thing is, when it Z-Hops, it literally stops moving. So Z-Hopping is stopping the print, raising the nozzle, waiting for that to happen, moving across, lowering the nozzle, which is another weight. You get the idea. So why? Well, it says it right here. These are the official reasons for Z-Hop existing. Preventing a scar from the nozzle hitting the print when it enters or presumably exits. Oozing causing blobs. And blobs caused by travel knocking the print over. The reason I particularly find this funny is because, as you know if you've been printing a while, that's the exact same list of things that Z-Hop is accused of actually causing. There's a further 2 unofficial reasons. I guess they're unofficial, it probably just depends where you read it. On the top surface you can get scarring, especially if you're ironing or doing monotonic infill. As the nozzle moves, it can take necessary paths around the top surface. That leaves a trench in your nicely ironed print. Monotonic means a neater top surface, and ironing is the process of making it completely smooth, or that's the idea. The other unofficial reason is noise. Now, in a huge ironic twist, those last 2 reasons I've just given you are the only ones I can actually support using it for. Kinda. So let's get to the meat of the episode. Does Z-Hop actually work? You would think not, based on what I just said, but it's never that simple, is it? I've got a series of tests to do to try to figure out whether there's any huge impact on any of the scenarios I've just mentioned, and this, as usual, turned out to be a rabbit hole. Z-Hop. Hop. Rabbits. Get it? Firstly, let's look at top surfaces. This does depend on the slicer. Back when I did a monotonic infill video some years ago, actually I think 2 years ago, time flies, the monotonic infill samples I printed were totally carved into when I printed them on Prusa Slicer, but less so with Cura. I've learned a lot in those 2 years though, and slicers have changed quite a bit, so I retried this to see if I could reproduce the problems I had. I've gone as far as to trying to reproduce the original scenario as best I can. It was the top part of an XYZ cube. I was obviously a lot lazier in those days. I didn't bother making my own models. There's nothing really to speak of here in terms of gouging. I tried a lot of permutations. Ironing on, ironing off, Prusa Slicer, Cura. I couldn't reproduce the gouging that I'd seen before. I don't know whether I did it on the Monoprice Mini Delta or the Ender 3, but the best I can show now is tiny marks where you'd expect them when you have ironing on, and even less obvious marks when you have ironing off. Exactly where the slicer preview puts them. They're more obvious when you have ironing on because the overall surface is smoother. They're not terribly obvious anyway, to be honest. So what changed? Well, I mean, maybe nothing. I'll come back to this in my summary later on. But is it worth using Z-Hop here? It depends. Now let's look at the print quality argument, and we'll go back to these viaducts that I used in the intro. Here is Z-Hop off, and this is the Creality Silk Rainbow filament. This is the kind of scenario that really ought to be able to replicate that curling of edges that you would expect, because you have overhangs and you have silk filament, which really likes to curl upward. And yet, it's not curling upward. When the head returns to print on existing layers, you can see there's really not much hitting existing parts happening, is there? And there's clearly not much bumping into the existing parts either. Here's the same part with Z-Hop on, and Z-Hop is set to a modest height. I think it's about a layer high. It's certainly working. You could see the hopping is actually happening, but you have to question why you need to do it in the first place, because it doesn't really seem to make any difference. Except we appear to be winning an extra prize in this. We've got all this weird fluff, which, by the way, we're going to see more of. The weird fluff or the fine stringing is a common issue with Z-Hop. When you lift the nozzle, you get this kind of weird candy floss effect. Thirdly, and this would previously have been my main reason for recommending Z-Hop in the past, this is the problem of hitting existing parts and knocking them off the print bed, especially when dealing with fine or thin and tall parts, and especially dealing with high speeds. Z-Hop is largely regarded as the main setting to counter the phenomenon of the printhead flying across existing printed parts during its travel moves, not during the print moves, and catching on the part of the print and knocking it off the bed. Or is it? I printed a whole bunch of different Agate print-in-place models. Sorry, I still don't know how to pronounce that. Check out the description for links to his work. Each one was printed once with Z-Hop off and once with Z-Hop on. These normally print absolutely fine as long as you've got your printer tuned correctly. I'm not going particularly slowly though, because I was actually trying to find a point where they would fail. It's entirely pointless if they all just print fine. Now, there is a small thread of possible evidence in favour of using Z-Hop here, as you can see, but this is very tenuous. On most models, there was very little difference in reliability and very little difference in how freely the parts moved after they were finished. To me, this isn't particularly statistically significant, but if you like, maybe the Z-Hop versions are slightly less likely to come off the bed while printing, but you have to deal with the extra stringing because, yeah, there's that stringing again. But it's not really good enough to start throwing around conclusions based on this data. I needed a test piece or two to really drill down into this point, or at least I thought I did. Meet this, whatever it is. This is twice in 2 videos now. I've made a mockery of Fusion 360, but this piece is designed to test exactly the sort of thing Z-Hop is supposed to fix. As the printhead goes round and round, these skittles are increasingly likely to get bumped and knocked over. It's a great idea, I thought. I'll just run this a few times on each of my printers and make a spreadsheet and see with Z-Hop on, Z-Hop off, see what the difference is, and we can have a look. The problem is, as I did this and I logged it down, it became quickly evident that none of my printers appear able to print this at all with Z-Hop on or off. Even with modest brims, it's still failing. I think I may have inadvertently created an unprintable print. I've actually shared it on printables. I'm curious to know if anyone can print it, so feel free to go and get it and see if you can. It's totally not my evil plan to get more Prusa meters, but no, seriously, I think you might be able to get this to work if you have a textured bed or you use glue. You need extreme bed adhesion. See how you go. Feedback to me in the comments or post makes on printables or something. Tell me whether you used Z-Hop or not, and that could be an interesting future video. And while you contemplate whether it's worth doing that, let's talk about this video's sponsor, PCBWay. PCBWay can cater to your PCB manufacturing needs. One of the things we do a lot as makers is electronics as part of our projects. I know we can all get a bit lazy and we end up designing stuff on breadboard and then we might make it on stripboard or whatever, but there is, of course, a better way. And that's to make PCBs. PCBWay can supply PCBs for just about any purpose in just about any colour with various colour masks too. You can even stick your logo on there using the mask. If you also need other services like fabrication outside of 3D printing, then PCBWay can easily and simply cater for that too. Even things like 3D printing in various metals if you need extra strong components in your build. PCBWay is an easy and convenient way to get low-volume parts made without hassle. Just upload your designs and pick from the options on the website. Go check it out now in the description. Thank you, PCBWay, for sponsoring this episode. I'm aware, thanks to Teaching Tech's latest video, that there are some novel Z-Hop methods in slicers other than Cura and Prusa Slicer. Orca Slicer, for example, has several Z-Hop methods. These presumably come through from Bamboo Slicer, which I've not used, and weirdly, so does Creality Print. These can be seen in action doing roughly what they're supposed to do, and they do look cool. But I didn't see them do what they're supposed to do, which is to stop these pins falling over, and please do test this yourself at home and report back. But why do these not help? Why do they not work? I'll save what I noticed and why I think these pin-based pieces won't print ever regardless. I'll save that for the conclusion. I want to finally talk about tree supports because this might be the potential last use case for Z-Hop. Of course it's not, obviously. Z-Hop doesn't make any difference here in my tests at all. Maybe it does for some cases, but I couldn't find them. We should then consider what's going on here. It's time for the long-awaited conclusion, and don't skip this because this is not a normal conclusion. I've hidden all the tips and answers in here. So, why do these pins fail? Let's watch the row of pins just as it fails. This is with Z-Hop off. See if you can spot what happens. It does appear that the nozzle is knocking over the pins as it flies past. But I'm being a bit disingenuous here. If you look at the routing I've set up for this part, Cura does not print these in left to right order. This is naturally how Cura works. It's hopping over ones it just printed. It doesn't do this if you have this setting switched on, and this is the buried lead in this video. Avoid printed parts is more useful than Z-Hop. If you turn on the avoid printed parts option, then the pins aren't knocked over by the head flying past because it doesn't. They do still get knocked over though, they always get knocked over, that's the thing. This is with Z-Hop on, you could see the hopping and you could see all the stringing caused by it. Here comes the failure, this is the failure that's supposed to be avoided by Z-Hop, and there we go, that's what I was expecting. You see, filament is viscous, and this viscosity is a non-negligible force. You can see on this half-failed piece just how large that viscous force is. In the results, I saw this failure almost every time. The sticky nature of the molten filament is what's actually pulling the part over. It's not the nozzle passing in or out. So there's a logical assumption here. If you can make the filament less sticky, will it fail less? Actually, yes. You can make filament less viscous by heating it to a higher temperature, and believe it or not, that actually does seem to work. This print, very, very nearly finished with the print temperature at 240°C on PLA. I don't recommend that. So, avoiding printed parts and raising the print temperature, not quite that high, are two potentially more reliable ways to prevent failure than turning on Z-Hop. In terms of scarring on top layers, I think you can decide for yourself if Z-Hop's downsides are worth the minimal gains that you might get by not using it. I would say generally no, it's not worth it, but there are some caveats. You might want a flawless top layer and have unavoidable travel moves, and this will necessitate turning Z-Hop on. And I'd advise looking at the preview in the slicer because that will literally tell you where those marks are going to be and how many of them there will be. In Prusa Slicer and presumably its derivatives, you also have this option, which is the Z-Hop only over a certain height, which I would really advise using if possible if you're trying to cure a top surface. It makes perfect sense. So it seems the ultimate answer is always some version of an instead. Instead of using Z-Hop to try and solve a problem, maybe try and find the root cause. Use different settings to achieve the same thing, or maybe try to design your part better for FDM printing if you're designing the part, by not creating weak parts in the first place. Know what kind of thing fails and avoid doing it. Or maybe tune your machine, or maybe print at a slower speed. Or maybe tune your flow correctly, or tune your temperature, or maybe just buying better filament. Almost every use case for Z-Hop seems to point towards some version of something else being a better solution. Z-Hop can, in fact will, make your quality worse, and it can, again, will, slow down your print. Z-Hop, in all likelihood, won't help you. What do you think? Do you have a situation where you're convinced Z-Hop did help and I'm full of gyroid infill? Let me know in the comments about your experiences, and also go and try that test model I've uploaded. No cheating. I mean, it should print. It's got no huge overhangs. I'm obviously just doing it wrong. Anyway, I will see you next time. Thank you for watching, and go turn Z-Hop off.